Hello everyone, I am Venkat Sheshu. My roll number is 254G1A47J8. I am from CATC section from SRIT. Today my topic is Mighty Queues. The Mighty Queue. Why order matters? Understanding the fundamental data structure that keeps our digital and physical worlds running smoothly through ordered processing. First, what is a queue? A queue is a linear data structure that follows a specific order for processing elements. Think of it like a line at a moving theater or a queue at a bank. People join at the back and are served from the front. This first in first out principle ensures fairness and predictability in processing requests, tasks, or data elements. Real world examples of queue: supermarket checkout, call centers, print spooling. First, supermarket checkout. Customers join at the end or served in the order they arrived, ensuring fairness. Next, call centers. Call centers. Customers' calls are answered in the sequence they are received, managing high volumes efficiently. Next, print spooling. Documents wait in the line to be printed, processed one at a time in the order submitted. And next, more properties of a queue. FIFO explained. First, what is a FIFO? FIFO is a first in first out. The oldest element is always processed first, maintaining chronological order. Ordered processing. Elements maintain their relative positions, ensuring predictable behavior. Fairness guarantee. Every element gets its turn without priority jumping or skipping. Key operations enqueue and dequeue. Enqueue means adds an element to the rear of the queue. This is how new items join the waiting line. Process. Elements wait in their designated order, maintaining the sequence. Dequeue removes and returns the element from the front of the queue. This serves the next waiting item. Other essential queue operations: peak or front is empty is clear sage. First, peak or front returns the front element without removing it, allowing you to inspect what's next in the line without dequeuing. Next is empty. Checks whether the queue contains any elements, returning to returning true if empty and false otherwise, essential for avoiding errors. Next, size returns the number of elements currently in the queue, helping you understand and workload or wait time. Next, clear removes all elements from the queue, resetting it to an empty state for a fresh start. These are the essentials of queue operations. Why queues are important? Efficiency, fairness. First, efficiency. Queues optimize resource utilization by managing workloads systematically. They prevent bottlenecks and ensure smooth processing flow. Fairness. The FIFO principle guarantees that every request gets equal treatment, building trust in systems and processes. Without queues, systems would face chaos, unpredictability, and inefficiency in handling multiple requests simultaneously. Applications in computers of queues, operating system, data structures, networking, application designing, operating systems (OS), task scheduling, print spooling, and interrupt handling all rely on queue structures to manage multiple processes efficiently. Data structures queues from the foundation for more complex structures like graphs, trees, and breadth. First, such algorithms. Next, networking. Data packets are queued for transmission, ensuring orderly delivery across networks and preventing data loss. Next, application design. Message queues, job scheduling, and request handling in web applications all implement Principles for reliability. Beyond the basics, advanced queue types. Priority queue, circular queue. First, priority queue. Elements are dequeued based on priority rather than arrival time. Higher priority items jump to the front, usual for emergency systems and task scheduling. Circular queue. A variation where the queues wraps around, reusing empty spaces at the beginning, efficient for buffer management and streaming applications. And next, summary and key takeaways. FIFO principle, essential operations, real world impact, foundation for complexity. First, FIFO principle. First in, first out ensures predictable, fair processing of elements in order. Next, essential operations. Enqueue adds to the rear, DQ removes from the front with peak, is empty and size for management. Next, real world impact. From supermarkets to operating systems, queues keep our digital and physical worlds running smoothly. Foundation for complexity. Basic queues enable advanced data structures and algorithms that power modern computing. The queue simply elegantly solves complex problems through order processing, proving that sometimes the most powerful solutions are also the most straightforward. And that's all about the queues. Thank you.